All right, let's start 2.3. These beginning problems or the beginning topics may seem weird and things like I just skip over that. I wouldn't. I just wouldn't. Take the extra couple minutes to try and get what's going on here, okay? Because it's going to pop up throughout the rest of the course, and I see students struggling with this in week 16. And if they would have put a little effort in right at the beginning, really try and get it, bother their teacher, bother their past peer, I think they would have got it. So let's get through it, and I'm just going to write in a couple of things. So this is something that is stated that we know sine on the unit circle is just y. Oh, I'm sorry, over 1. I'm sorry, I forgot to put that in there. And cosine is just x over 1. Tangent is y over x, cosecant is 1 over y, secant is 1 over x, cotangent is x over y. But we go back to this idea of domain. Domain. What are we allowed to plug in? How do we make sure that we don't divide by 0? And that's what this is telling us here. Tangent has a problem. You can't plug in anything you want to. It's really bad. And I think secant has the same issue. Look, they both like x can't equal 0. And then if we look at cosecant, we got a y in the bottom. So we're like, well, y can't equal 0. And then cotangent has a y in there. Oh my goodness. So we're going to talk about what we're allowed to plug in, aka domain. This is one of the most important things to learn, yet a lot of us struggle with it. And it's not too much, just don't divide by 0. So you're going to get some stuff and it's going to give you the words. The domain of the tangent function is the set of all real numbers except odd miniature multiples of pi over 2. You're like, well, what the hell does that mean? That's a bunch of words. Well, I'm going to try and do my best to show you. So let's talk about sine. In domain, these are this is what you're allowed to plug in. It used to be your x values. Now it's your angles, right? We're plugging in thetas into here. That's like your new x. For trigonometry, theta is your x. You know that thing in algebra you were constantly, your teacher's asking you to go find? Yeah, it's kind of the same thing. So we look and we go, well, is there any angle we're not allowed to plug in? Well, there's no domain issue. So we're allowed to plug in anything we want. So this would be negative infinity to infinity. The same thing's going to be true for cosine. Negative infinity to infinity, because we have no issues. We can plug in anything we want to into sine or cosine, and those are angles. These are angles. Remember, Greek angles. Greek are angles. English, ratios of a triangle. So now we start to look at tangents, and we're like, uh-oh. You're not allowed to plug in any x's which equals 0. So where is x equals 0? Because I have this little graph thingy here, and it just gives you just the quadrantial angles. We use that term. It's not neither quadrant. It's not in quadrant 1. It's not in quadrant 2. And we move in this direction, right? We go around in a circle. And we start thinking very circular in the class with these angles. But the x-axis is where y equals 0. The y-axis is where x equals 0. Do you catch that? You know, like x equals 1, 2, 3. So if we go backward, 3, 2, 1, 0, we're on the y-axis. It's backwards, right? It doesn't seem right. We're backwards. So what we're saying when we go back to our tangent and it says x can't equal 0, it's saying you can't plug in any of these values. You can't plug in 3 pi over 2. You can't plug in pi over 2. You can't plug in 90. You can't plug in 270. Oh my goodness. And this is going to pop back up. It's going to be over and over and over. We're going to use this. So what we're going to say now, this gives you some weird thing. I'm going to write it out. Oh, the domain of tangent is everything except angles which equal some pi over 2 plus a pi k. And you're like, what the frick are you talking about? Pi over 2 plus pi k? What the frick? Basically, we're saying everything except pi's over 2. And to talk about this, we're not allowed to put in any pi's over 2. But, let me write it differently. And here's the term. Odd multiples of pi over 2. And take a second. I know you want to skip past this. I know you don't want to look at this. But please. So here's an odd multiple of pi over 2. 1 pi over 2. That's what we have written there. 3 pi over 2. 5 pi over 2. 7 pi over 2. 9 pi over 2. What's not an odd multiple of pi over 2 is 8 pi over 2 because it reduces down to 4 pi. Our game is going to continue. So that's not one of them. That's all good. That's not a problem. It's whenever you have a pi over 2 and you can't reduce the 2 in the denominator. You're not allowed to plug it into tangent. You're going to get an undefined answer. It will be undefined. So any multiples. But similarly, when you're talking about angles, 90 degrees isn't cool. 270 degrees isn't cool. 450 degrees isn't cool. 540 is fine. 630 isn't cool. Because if we keep going around in the circle, we get to 90, come around to 270. And once we come back up here, we're adding 180 to this. Or we're actually adding 360 to 90. And that's going to be 450. And then we could add 360 to that thing again. 6, that's a 1, 3, 8, and then 8, 10. So the degrees are a pain in the ass because you can't just look at it. You can't just look at it. If you tell me tangent of 17 pi over 2, I'm like, sweet, that's undefined. But if you tell me tangent of 1,980 degrees, I'm like, I don't freaking know. I got to subtract a bunch of 360s to figure out whether it's undefined. All right, well, let's pick up the pace. I did the explaining, but if you could look in purple, we up here in the highlights, we're going to find also domain of tangent and secant because they're dividing by the same things. They're both dividing by x. Now to do our last one with our cosecants and our cotangents. So the domain of cosecant and cotangent is everything. But can you see which values? Multiples of pi. Look at where y equals 0 back here. It's right here. So we started off with 0 pi's, 1 pi, 2 pi, then we get 3 pi, then we get 4 pi, then we get 5 pi, then we get 6 pi, then we get 7 pi. So anything with no denominator, well, actually it's got a 1 in the denominator, those are really bad for cosecant and cotangent. This is also, we could write it as multiples of 180 degrees. Sorry for the crappy thing down. So that's the start. What are we allowed to plug in? And I'm going to show you other tricks as we go through to quickly find those so you don't have to have them all memorized. I don't really keep this locked in. Cosecant, cotangent, secant, nah, I don't keep those locked in. We got tricks. We got ways to where you don't have to memorize all that. But the one I need you to memorize. The domain of tangent is everything except for odd multiples of pi over 2. That's where I'm going to try and trick you. Just straight up. It's going to pop up. But we're going to keep working through and we're going to see other ways of doing this. So this is the beginning, kind of building it up. And you're like, this stuff sucks. Give it time. It's not that bad. It's not that bad. All right. Well, okay, maybe it is. I don't know. It's my perspective. I don't know. Maybe it's terrible. Maybe it's the hardest thing ever. Maybe it's simple for you. We all come from different backgrounds. You are where you need to be. Just keep grinding. That's it.